Okay, so this talk is really about the crazy service mesh ecosystem out there. I was just talking to one of the gentlemen there. It was like 2 years ago, there was only 1 or 2 projects, but now it's like 10 projects out there. So before we talk about each of the service mesh implementation, I'd like to start to talk about why service mesh. Why are we interested in service mesh? Why there are so many projects out there providing service mesh solution to you as a user? Can you guys see my slides in the back? Okay. Okay, good. So this code might sound familiar to you. So it's basically a HTTP client tries to call a service to get some secret source recipe, and it needs to handle network error and says, please fix the network error for me. How many of you were in my session this morning? So I can get okay, a few of you. So I'll try to run this a little bit quickly, but many of you aren't there. Now you may want to have no balancer because you want to talk to a specific endpoint. So you would add typical code to look up the service in a specific way to either round robin, or maybe you have some sophisticated algorithm for load balancer to look up that secret source service to get the recipe. Now, you probably want to think about, I can't trust the code, just do it one time. I'm going to try it at least 3 times. And then if it actually fails at the second time, I'm going to put a little bit of sleep in there because I want to have a little bit extra time to try it. And also, you don't necessarily trust all your services to communicate to each other. When you talk to the secret source services, you actually have to have certain authorization with certain keys to talk to the services. So this is the code that comes in, allows you to build the secret, to actually set it as the header when you talk to the target service, which is secret source in this case. And logging is also people's favorite because you need that to troubleshooting problems. So you would need to log success and failure. This is the stats provided by Kubernetes. The really basic stats, as you can see, you can't really see much other than CPU and memory, other than the pods are they are active, healthy. That's pretty much it. So now I want to imagine you have many services, and some of your services probably would look like this room because it has the retries we talk about. It has the service secure communication, try to handle secrets, authorization we talk about. It has the networking error, trying to retry to handle networking error. It has the logging we talked about earlier. So your services may not be able to focus on the core essential piece and function of your services. And also, if you think about it, you might have multiple languages. And when you have multiple languages, you have to write all that, what I just showed you, differently for each of the languages. So we got developers thinking, really each service owner needs to build all these functionalities that's not even related to my services? And then the operation team who supervise many of these services would be thinking about, can we really trust each of the service owner to build all these functionalities that's plopping functionalities consistently? Can we trust them to do logging? Can we trust them to do secure communication? Can we trust them to do circuit breaking retry consistently? So that comes down to the problem domain we just explained, comes down to what exactly is service mesh. So to me, service mesh really provides you is a storage box that can sit next side of your services to extract the long essential piece of your services and put that into the storage bin. So that gives you, for your services, to focus on the critical pieces of your services and then you have the long essential pieces to delegate that to the sidecar proxy, in this case, which is the storage box. And then you actually have a consistent storage box to handle for all your services, regardless what languages your service are written in. So to summarize, a service mesh is really language neutral, regardless what languages your service are written in. It provides a dummy initialization of that storage box, which is sidecar proxy. And by doing that instantly, you immediately get visibilities. And the reason I put a visibility plus there is not only you get visibilities, you actually also get retries automatically. I believe we do 2 times retries by default. Optionally, the service mesh provider also exposes API, allow the users, like developers or operators, to program the attachment so that it can be smart, so it can allow them to do A/B testing, to do canary testing, to be able to do secure communication, to be able to do authorization. So that's all through the programming part, typically using a YAML configuration. So before service mesh, you would see a programmer or a user to visit your services through an ingress typically, and then go through the service A and service B. With service mesh, when the sidecar proxy is added, the service is not going to go directly to service A. It's going to go through the sidecar proxy because that proxy is going to capture all the inbound traffic and then forward that to the service A. And then when the service A wants to call another services, it would also go through the sidecar proxy of A and then goes to B, depends on whether service A is even allowed to talk to service B. And through the programming portion of programming the mesh, you could also enable mutual TLS. You could do intelligent things, like we talk about A/B testing, circuit breaking. So all that's possible for you. So in summarize, service mesh really provides language-neutral standard attachment to your application container. It provides user interface to allow you to configure policies for that sidecar proxy, and most importantly, without you needing to redeploy your services. So you can keep your service intact, but just apply the policies on top of it. It also enables clear separation from the application developer who focus on their application, and then the operation team focus on how do they program the policies for the sidecar proxy. One thing I would like to everyone really is take a pause to think about, do you really need service mesh? Because we actually find out not everybody needs a service mesh. Service mesh is actually complicated because of the sidecar proxy, because of the control plane. So you have to look at, do you really need microservice architecture? Do you really need to have your services to be delivered by different team, by different schedule? That's when you really want to look at service mesh to help you to solve those problems. So let's talk about navigating the service mesh ecosystem out there. To me, there are a couple of key aspects you really want to look into when you look at the service mesh ecosystem out there. So you want to check if it's an open source project. Is it governed by a diverse contributor base? That's really important for the health of the project. Does it use a proprietary proxy for that sidecar, that attachment we talk about? Is the project part of a foundation? Does it also contain all the features you need? And also, does it really integrate very well with your existing environment? Because you have to look at your legacy system to find out whether it's a match there, whether it supports it. So a couple of key players here. How many of you heard of Envoy? Okay, wow, lots of you, very good. So Istio, I think we did a pool on Linkerd. Consul Connect. How many have heard of a Consul? Okay, Consul, a lot of you, that's great. AWS AppMesh, couple of you. So Kuma, any of you heard of this project? That was just announced last month. Aspen Mesh. A couple of you, service mesh interface. A few of you, very good. So Envoy was created at Lyft. It's graduated CNCF project. You guys probably see this curve. I think it was published like 2 weeks or 3 weeks ago by CNCF to show the tremendous growth of Envoy. What's really interesting of Envoy, I think it's battle tested at Lyft in production environment. It's tested on over 100 services, spanning 10,000 VMs, processing 2 million requests per second. So it's really large-scale deployment. And it's well, the other thing really interesting of Envoy is it provides out-of-process architecture. So it enables us to take Envoy as a building block for service mesh because of the process architecture, so we could potentially use Envoy as a sidecar proxy. And Envoy also supports sophisticated, advanced load balancer, different capabilities. You name it, Envoy probably have it for load balancing. And the other thing really cool with Envoy is it provides API to do configuration management. So if you are a service mesh provider, it's important that we could actually looking at the API to program Envoy. One thing really interesting of Envoy, I think also part of why the project is so successful, is you look at the contribution diagram of Envoy, it's just super, super healthy. And Google is the top contributor. I think Lyft is now number 2. Red Hat and IBM, I think it's number 6 or 7. But so it's really, really diverse. That's what you want to see with a health open source project. Istio is a project that's been 2 years old, and it uses Envoy as sidecar proxy. It's also open source service mesh. It's made of 300 companies and 400 contributors. Very, very rich feature set. Istio is known for probably the most advanced service mesh project out there. The other thing really interesting is Knative, which is Kubernetes-based platform to deploy and manage modern serverless runtimes. Knative is also built on Istio, at least today. If you look at the Istio's contribution diagram, I would say it's not as nice as Envoy. So Google is the top contributor to Istio, and everybody else combines, with IBM being the second contributor. It's probably about a little bit over half of what Google contributes. So it's still very diverse. It's just not as diverse as Envoy. Linkerd is a CNCF incubating project. It's also an open source project. One thing Linkerd team does really interesting is they use homegrown sidecar that's written in Rust. They actually rewrite all their sidecar just recently, about a year ago as part of a Linkerd 2.0. And they are also relative feature rich. This is for mutual TLS. They have the basic observability, traffic shifting, not as feature rich as Istio, but basic functions are definitely there. And the team really focus on Kubernetes, make it really work well for Kubernetes. So Linkerd has been really known for people to get started to use Linkerd really easily, and they request 0 configuration for some of the mesh functions, such as mutual TLS. So it's a great project out there. One thing about Linkerd is it's not using Envoy because they're using their homegrown proxy. The other thing is their contribution is not as diverse as Istio or Envoy for sure. So it's primarily by this company who founded Linkerd called Buoyant. Linkerd also has a really nice dashboard, as you can see. So the dashboard has different functions that you can actually see graphics for your workload. You can also do a tab, shows the stream of requests across the single pod. You can also display information about live traffic through the top commands. So it's a nice dashboard they provide. Consul Connect was developed by HashiCorp. It's an open source project. It really extends the existing Consul offering. So if you're already a Consul user, I think it's no-brainer. You want to look at this project. It uses Envoy as a sidecar. It provides integration with Vault to help you manage that certificates used to communicate, secure communication of the services. It also supports the key features of service mesh, such as mutual TLS, traffic management at layer 7, and observabilities. AWS AppMesh, I would say this is really pretty much a cloud services hosted by AWS. It's not really open source per se. The most important thing about it, I think it supports all the compute services in AWS. So it supports the AWS ECS, Fargate, EKS, and EC2. So if you're already an AWS customer, this is worth looking at. It has similar control plane as Istio, but you're pretty much locked in with AWS. This is a new project I just mentioned, Kuma, that was launched a month ago. It's a universal control, open source control plane. It also uses Envoy as the sidecar proxy. What Con does really interesting is they actually have, they support multi-tenancy. They also have simplified control plane. They have one single component for control plane. So really, really interesting. Aspen Mesh is a supported distribution of the Istio project. This is when you see a vendor who is rally around open source project like Istio. They're trying to sell support of Istio. They have a UI and dashboard to help user to manage looking at the Istio resources, identify problems. So really useful. So very interesting. Istio, this is something definitely worth checking out too. Service Mesh interface is relatively new. It was launched at KubeCon Europe 2019. It's primarily funded by Microsoft with a couple of partners out there. It's really an attempt to find a common ground for Service Mesh on Kubernetes. So if you're familiar with Kubernetes, then you can think about SMI like the container runtime interface. So container runtime interface is an abstraction for container runtime for Kubernetes. There's Docker and Containerd. So what Microsoft is trying to do is to have that common ground of Service Mesh interface. Sorry about that. In looking at the Service Mesh interface at the Service Mesh projects at CNCF Landscape, I actually learned something new recently too. So there's this new project called Gray Matter. There's also Mesh project. There's also Netflix OSS 2, which I already know. I think that's a pre-version of Service Mesh. It's so much focusing on using single programming languages, but not so much on having that sidecar proxy work across all the languages, regardless of what your service is. There's a super glue. There's also a WAMP project. I would say, I think Gray and Master and also Mesh, they are a little bit early to be evaluated. Some of the documentation are not there. They don't have like good demos out there. Superglue, I think it's an interesting play out there. It's an open source project, really opinionated abstraction layer that simplifies installation, management, and operation of your service mesh. Superglue actually exists before Service Mesh interface exists. So I think it really helps shape us SMI. WAMP, I think it's a little bit too early. It's a startup that was founded around KubeCon Europe. I find most of their documentation are not super accurate. At least I think the team's still working hard on that. So I think I'm not going to have time for demo. So I do want to mention a quick thing about this book that's coming up. So authored by me and my friend Dan Berg. So it's going to be a preview around KubeCon US in November this year. And we expect the final book out towards the end of the year. So this is something, if you're interested in Service Mesh, if you're interested in Istio, I recommend you to check it out when it's available. I will be here and also outside to answer any questions you guys have. Thank you so much.